Okay. Good morning, all of you. Welcome to this lecture of refrigeration and air conditioning. So today we'll take the first revision of last lecture, so that practical absorption refrigeration cycle. Then we'll see some types like lithium bromide system and Electrolux refrigerator. So before that, those who are having backlogs in last year, I have provided one university form. Make sure you have filled the form. Okay. So those who have cleared the backlog subjects, so they should text me or contact me personally. So already Prajwal Khadke, hopefully they have contacted me. Others who are having backlogs, they fill that university form and choose the option yes for online conduct of exam. So those who are regular, make sure you are stay alive in this pandemic situation to give the exam. Okay. Okay, so we'll take first revision. We have a lot of time in this pandemic situation. We can go as slow as possible, and I'll give more and more explanation for these things. Okay, so in last lecture we have studied the practical absorption refrigeration cycle. Why it is separated from simple? Because in simple we didn't have this absorber, heat exchangers, and rectifier. Okay. So we have absorber extra in this system, then we have a heat exchanger here, and we have a rectifier here. Okay. So in general, I will tell you again, repeat the process of vapor absorption refrigeration cycle. So we have a evaporator, which is whose whole objective is to extract the heat from low temperature reservoir. We have no objective. So in that we have this refrigerant solution, and this refrigerant will extract the heat. This refrigerant will be passed to the absorber. Okay. In absorber we have absorber. So this refrigerator will be absorbed, and this is the absorber. So absorber will absorb the absorbate. The strong solution is formed. That solution is passed to the pump. Wait a minute, I have some disturbances. Okay, so this strong solution is pumped. So in this case, what we are doing, we are replacing the compressor of vapor compression system by a pump in vapor absorption system. The strong solution will be passed to the generator. Okay, before that we have a heat exchanger here. So दोन गोष्टी नेहमी लक्षात ठेवा की जे जनरेटर कडे जाणार आहे, so generator we are supplying the heat, so that temperature of this solution should be higher. Okay, and this absorber we are always maintaining lower temperature in absorber. Okay. Why? Because at lower temperatures only this absorption process will take place. So we want to make sure that temperature here remains lower, and we want to make sure temperature in generator remains higher. So that is why we are supplying the heat exchanger here. Whatever solution which is going to the generator, this temperature will be higher. Whatever temperature coming from the generator, so this temperature will be lower. Okay, so there will be heat exchange. Temperature of strong solution will be higher, temperature of weak solution will be lower. Then this strong solution is passed to the generator. Okay, and then what happens in generator, we supply the heat, and because of difference in boiling point temperatures, so that ammonia is separated and it is passed to the condenser. Water is separated, water is passed to the absorber. So there are two circuits. One is the absorber circuit, another is the absorbate or the refrigerant circuit. Okay. Again, in this case, what happens? We are using an analyzer. Analyzer is nothing but a series of arrangement of zigzag baffles in which the solution is passed. And what happens? Water drips through these surfaces. Water is separated, and ammonia gas is separated. It is passed to the rectifier. Again, in rectifier, again we are cooling this solution. So because of again difference in condensation temperatures, ammonia gas is separated, it is passed to the condenser. Again, water is collected, it is dripped back to the analyzer and generator, and then again to absorber. So this ammonia gas is passed to the condenser. It is cooled. It is converted into the liquid ammonia. It is passed to the expansion one, and again it is passed to the evaporator. So this way the cycle of ammonia, or we can say refrigerant, is completed here. Okay, and the cycle for water is from absorber to the pump to the generator. Again, there will be some pressure reducing valve here. Then again back to the absorber. So this is a general cycle for water. In practical, we are supplying one heat exchanger, we are supplying one analyzer, and we are supplying one rectifier. So this we have seen in last lecture. Okay. So today we'll see lithium bromide vapor absorption refrigeration system. So what you see on the right, so this is a general system or a actual machine which works on lithium bromide and water solution. So in our previous system, we have used ammonia as a refrigerant and water as an absorber. Reverse is in the case of lithium bromide. In this case, lithium bromide, this is like one salt. This will act as an absorber and water will act as a refrigerant. Okay. So what we studied previously, aqua ammonia. In that case, ammonia was refrigerant, water was absorber. In lithium bromide, in this case, lithium bromide is the absorber and the water is refrigerant. Okay. So what it says, vapor absorption refrigeration system using water, lithium bromide pair are extensively used in large capacity air conditioning systems. In this system, water is used as a refrigerant and solution of lithium bromide in water is used as a absorbent. Okay. It is only in application require refrigeration at temperatures above 0 degrees Celsius. Because we are using water and the boiling or freezing point of water is 0 degrees Celsius, we cannot go below 0 degrees Celsius. Okay. In that case, we have to we can achieve the temperatures. Let us say maximum 2 degrees Celsius, 3 degrees Celsius, but we cannot go below 0 degrees Celsius. If you go 0 degrees Celsius and the pressure is atmospheric, in that case, what will happen? Water will freeze, and that whatever tubes of evaporator or condenser, that they will be choked. So we want to avoid that, so we cannot use below 0 degrees Celsius. Since water is used as a refrigerant, using this system, it is not possible to provide refrigeration at sub-zero temperature. So that is what I just explained. So we cannot use it below 0 degrees Celsius. The analysis of this system is relatively easy as the vapor generated in the generator is almost a pure refrigerant. So why we are using lithium bromide or what is the advantage of this is, in case of aqua ammonia, we have to use the rectifier analyzer in order to separate ammonia from the water. In this case, it is not required because of their physical properties. Okay, so the analysis of the system is relatively easy as the vapor generated in the generator is almost a pure refrigerant. Okay, so that content of lithium bromide will be very less. Unlike ammonia water system where both ammonia and water vapors are generated in the generator. Okay, so even if we separate vapors in generator, some amount of water will be present in the ammonia in case of aqua ammonia systems. But in case of lithium bromide system, the chances of absorbent, so in this case absorbent is lithium bromide, chances of lithium bromide in the water will be very less. So I'll show you the diagram which is provided in the textbook. It is quite a bit complicated. I'll also give you very simply a file diagram for it. So let us first see the diagram which is provided in the book. So this is the system in front of you. It may look complicated to you. So let me guide through it. So what you see on the screen, there are two assemblies. Okay. So in one assembly here, there is one shell is provided. So in this shell, generator and condenser are compiled together. Okay. They are grouped together in one shell. In another shell, what you see here, this absorber and the evaporator, they are grouped together. Okay. So once you understand this, the rest is very simple. Rest we are again here. One we have heat exchanger, then we have a pump. Okay, so this is the main pump which will replace the necessity of compressor to increase the pressure, and then we have the other tubing and piping system. Okay, so in this case, this generator and condenser, they are grouped together in one shell, and evaporator and absorber, they are grouped together in one shell. Then we have a heat exchanger here. So let us see what is happening here. Okay. So in this case, in this shell, there will be absorber which is present here. Above in the shell, there will be a tray which will contain the evaporator. Again, in this another shell, there will be the strong solution will be present. In that shell only, there will be a tray or like arrangement in which that condenser will be present. Now we'll go through the cycle. Okay. So in this case, what is happening? There is an absorber in one shell, and this evaporator, the refrigerant in this case, it is a water, and this absorber is nothing but lithium bromide salt solution. So in this case, that water after coming from the evaporator, so that will be sprayed or that will be supplied to the absorber system. So a strong solution is formed. Again, the strong solution is passed through the pump. The pressure is increased. It is passed through the heat exchanger. So I told you previously, the strong solution which is going to the generator, its temperature should be higher. The weak solution which is coming to the system, to the absorber back, so its temperature should be lower. Okay. So in this case, what is happening? So this solution, it is passed to the heat exchanger. So it is called as weak lithium bromide solution, or we can say strong water solution. Okay. So in this case, this solution it is passed to the generator. In generator, we know that heat is supplied, so there is heating coil is present. This will increase the temperature because of difference in boiling point temperatures. So that water will be separated and lithium bromide salt will be separated. So this water will be supplied to the condenser. In condenser, we have this cooling water tubing, so that cooling water will be taken out. Okay. So again, whatever lithium bromide is remaining, that will be passed again back to the absorber. So this system is quite a bit complicated if you see on the screen. Let me give you some simplified diagram for this. Okay. So this is a simplified diagram for the lithium bromide system. I think this is much more simplified here. So in this case, as you can see, there is an absorber. Okay. And there is an evaporator separate here, but in actual that this will be grouped together. Then we have a generator here, and then we have a condenser. These are again grouped together in actual lithium bromide system. Okay, so absorber and evaporator, they are grouped together. Generator and condenser, they are grouped together. But for the simplicity purpose, they are showed here separately. See that again, what will happen here in this case? Whatever water present in the evaporator, that will be taken out. It will be passed to the absorber. In absorber, that lithium bromide will absorb the water. The strong solution is formed. It is passed through the pump to the generator. In generator, heat is supplied with the help of heating coil. The temperature is increased. So because of difference in boiling point temperature, water will be separated. Lithium bromide solution will be separated. This lithium bromide solution will be passed back to the absorber. Okay. And this water vapors coming out of generator, these are passed through first condenser. So these are cooled with the help of a cooling water. So there it may be air cooled, it may be water cooled. So these water vapors again pass to the evaporator. In that case, its function is to extract the heat from the space. So it will be used in air conditioning applications. So that heat is absorbed. Its temperature increases, again it is passed to the absorber. So this is how the lithium bromide system works. So whenever they ask for a lithium bromide system, always remember absorber and evaporator, these are grouped together. Generator and condenser, they are grouped together. Why we are using this, or what is the advantage in this case? There is no need for rectifier or analyzer. Okay. So because rectifier analyzer were used in previous system, aqua ammonia system, to separate the water vapors from the ammonia. In this case, it is not required because of physical properties of lithium bromide and water. Okay. So draw this diagram. This is a simplified diagram. This is actually actual diagram. This is a bit quite complicated. You can draw this in assignments, but for in this lecture you can draw this. So start drawing this diagram. I'll give some 5 minutes. Okay, completed. So in this case also, that the COP, coefficient of performance, for formula will be same. So that formula we have already seen in last lecture. So this was the formula here. So COP will be equal to TG minus TO divided by TG into TE divided by TO minus TE. So TG is nothing but temperature of the generator. So TO is nothing but the temperature of condenser or absorber. So it is assumed that the temperature is same. If it is not same, in that case, this TO will be replaced by TA. So TA is the temperature of absorber. Into TE, TE is nothing but the temperature of the uh, evaporator divided by TO minus TE. So TO is again temperature of condenser or evaporator. If it is not same, then this will be temperature of condenser. Okay. So this formula will be same for this lithium bromide system. Okay. So we'll move towards next system, and this is the last part, that is the Electrolux refrigeration system. Before that, I will show you this laboratory trainer kit. So we have this experiment related to vapor absorption refrigeration system, and this trainer kit we have in our laboratory. So this is a experiment on VARS system, vapor absorption refrigeration system. So this is the trainer kit here, and the objective here is again to calculate the COP of the system. Its schematic is shown on the right side. So one, you want to see here this plates. This is a plate heat exchanger that acts as a condenser. Then two, here it is again another heat exchanger which acts as a evaporator. Three is nothing but that absorber, what I told you, in which that mixing of absorber and absorbent takes place. In here, this vertical shell, what you see here, that is nothing the burner, or you can say the generator in which the heat is being supplied. Then this electronic, this temperature and pressure, this displays and controls will be shown here. So our objective in this case will be again to calculate the COP of the system. Unfortunately, during this lockdown period, we are not able to attend the college, and so we cannot conduct the experiment. So whenever that college resumes, that way in that period we'll take this experiment. Okay. Okay, so moving on, another system and the last part of this chapter, it is a Electrolux refrigeration system. So this is not nothing but a very big concept and innovative concept and breakthrough idea. It is very old idea, and in 1950, 1960s, this Electrolux refrigerators were introduced. So we'll see what are those. So see here in this system, the main advantage or the feature of this system is they have omitted the pump part altogether. Okay, so we started with VCRS, which has a compressor. Then we came to VRS, which replaced the compressor. Then we have Electrolux, we have replaced the pump part also. Okay, so you may wonder, sir, without pump, how that refrigerant will flow in the system. So in this case, what they have done, they have taken the advantage of gravity. So refrigerant will flow in one part of system, that is the lower side, under the effect of gravity. Another part, what will do, they will use the hydrogen and they will increase its rate of evaporation. So in that case, that rate of evaporation increases, and that way that pressure difference is generated. So because of pressure difference and gravity, we are achieving this flow of the refrigerant inside the system. Okay. So in previous VRS system, we have used pump. In this case, we are not using pump. We are taking the advantage of gravity as well as the pressure difference. So this type of refrigerator, I will read it out. This type of refrigerator is also called three fluid absorption system. Why it is called as three fluid? Because we are using ammonia, we are using water, we are using hydrogen gas. The main purpose of this system is to eliminate the pump so that in the absence of moving part, the machine will become noiseless. So again, coming back to the VCRS, we were using compressor. We don't want compressor because of its vibration and noise. Then we switch towards the VRS, which used a pump. Again, that pump will produce some noise. If you want to omit that also, if you don't want little bit noise and vibration, then you can omit the pump part, then you can go for the Electrolux refrigeration system. Okay. So in absence of moving parts, the machine will become noiseless. The three fluids used are ammonia, water, and hydrogen. Hydrogen means hydrogen gas. The ammonia acts as a refrigerant. So obviously this is aqua ammonia solution. So in that case, ammonia will act as a refrigerant, water will act as an absorber, and hydrogen. So hydrogen's function is here to increase the rate of evaporation of ammonia. Okay. So that I will explain in the diagram. The hydrogen, being the lightest gas, is used to increase the rate of evaporation of the liquid ammonia passing through the evaporator. Water acts as a solvent or the absorber. So coming back to this system, so all these parts, major parts, absorber it is there, generator it is there, condenser, evaporator, expansion valve, those systems will be there. And we have a heat exchanger here, we have a rectifier here. But the thing which is not present in this system is pump. So previously we had a pump here before a generator, so that is being eliminated. So how the system acts? So see here, starting from the absorber. So in absorber, we have this strong solution of aqua and ammonia, water and ammonia. It will pass through the heat exchanger. Okay. So this will flow under the effect of gravity. So no pump is needed. It will be passed to the generator in which the heat is supplied. Because of difference in boiling points, ammonia will be separated. It will be passed to the condenser. Okay. First it will pass to the rectifier. Water vapors are removed, if any. Then it is passed to the condenser. It is converted into liquid ammonia. And whatever water is separated, it is passed through the absorber. Okay. Then whatever liquid ammonia coming out of the condenser, it is passed to the evaporator. Now this interesting part comes here. Hydrogen is mixed with this liquid ammonia. So whenever any lighter material or lighter gas is mixed with a denser material, in that case what happens, the rate of evaporation increases. Okay. So hydrogen is mixed with this liquid ammonia in the evaporator. In that case what will happen, rate of evaporation will increase. So what is this rate of evaporation? That means in less time this liquid ammonia is converted into vapor ammonia. So lesser the time, lesser will be lesser the time, then in the less period we can freeze the goods or the materials. Okay. So if I'm using any fridge with the help of this evaporator, so in less time I will get that refrigeration effect. Okay. So as the rate of evaporation of liquid ammonia increases, greater will the lesser will be time required for the refrigeration. Then again in this case, this solution, it is passed through the absorber. In this case, what will happen? Hydrogen being a gas, it will be automatically separated. Again, it will pass through the evaporator. Then we have here only ammonia, which will come to the absorber, in which it is absorbed by the water. A strong solution is formed, and that strong solution is again passed to the generator. So we have three circuits in this diagram. Okay, so in previous VRS system, we had two circuits, one circuit for water, one circuit for ammonia. In this case, we have three circuits. So we have this water circuit from absorber to the generator back to the absorber. This is the water circuit. Then we have ammonia circuit, which is through the generator, through the condenser, then through the evaporator, then through the absorber. This is a refrigerant or the ammonia circuit. And third circuit is hydrogen circuit. So hydrogen circuit is absorber to the evaporator to the back to the absorber. Okay. So whenever I say Electrolux refrigeration system, first thing should come into your mind is that there are three fluids. One is ammonia, another is water, third is hydrogen gas. Okay. So that is why it is called as three fluid absorption system. Okay. So today we have learned two things. First was lithium bromide system. So advantage of lithium bromide is that because of their physical properties, this rectifier and analyzer, they are not needed. Whatever you get out of the generator, that will be pure water. So water will act as a refrigerant. That is why we are separating water from the lithium bromide salt. Because of their physical properties, there is no need for a rectifier and analyzer. Okay. And next thing we have seen here is Electrolux refrigeration system. In Electrolux, why we are using Electrolux? Because in this case, we don't want any moving parts. So moving part in VRS, it is a pump. So that pump part is whole together eliminated, and whatever flow of the refrigerant in this system, it is achieved by gravity and pressure difference. Okay. So this is about the Electrolux refrigeration system. So you go through the textbooks. I will provide these PPTs. Also, there is some PPTs from the NPTEL that will also I will provide you. So in that case, you will get a thorough explanation of these systems. I'll show you some advertising being made for this Electrolux refrigeration system back in 1950, 1960s. So this was the model, first model, which was introduced in 1933. So this is based on Electrolux vapor absorption refrigeration system. Okay. So these were very many refrigerators we can see. So see here, this is a condenser here. So this is a generator, vertical burner, which we have seen previously. So this is a generator, this is a condenser. Inside there will be evaporator coils inside this fridge. Here we have this absorber. So in absorber, this aqua and ammonia, water and ammonia solution will be formed. Okay. And in this case, heating coils are being used to increase the temperature inside the generator. So this is the Electrolux ammonia system. Pump is not used in this case. Okay, so I have one question here by Rohit. Why it is called as Electrolux? What it means? So Electrolux actually it is a company, and this concept was patented to that company. Okay, so elimination of pump and flow of refrigerant under gravity and pressure difference. That technology was patented to Electrolux, so that is why it is named under Electrolux ammonia refrigerator. So this is the advertising picture from that time, which was introduced in 1925. So you can see this is very old technology, and two girls they are sharing the Coca-Cola bottles, which obviously were stored in this fridge. And this fridge, when it was introduced by Electrolux in the 1930, 1925, in that case, this kind of advertise they used to make in paper. So nowadays, we have very fancy advertisement, but that time also in newspaper they used to make this advertisement. So this is the advertise for the Electrolux refrigerator. Okay. So as you can see here, there is a marketing strategy they have employed here. So husband expects lower operating cost, freedom from repairs, absolute silence, prompt gas company service, plenty of ice cubes. So that is what the expectation of husband. His wife will expect constant and steady cold, no bothersome defrosting, regulator to speed freezing, trays that can release easily, split shells for extra bottles. So obviously, woman will expect more space inside the fridge because they are the one who are going to use it frequently. Men will expect that it should be very less costly and it should not uh, mm, cause you regular maintenance charge. Okay, so obviously that will be part of men, and women will expect that it should give you more refrigeration effect and that space should be more. So that is how they used to make this marketing in that era. So this is dated to July 29, 1933. So this is a paper, the Saturday Evening Post in 1933. Right. Nowadays, this digital marketing platform, it is used mostly for the advertisement. We get advertisement while we watching YouTube videos. We'll get advertisement in Facebook, in Instagram. So this way they are now marketing these things. And newspapers less emphasis is given on newspapers. Mostly they go for this social media and digital marketing. Okay. So this was about lithium bromide system and Electrolux system. And soon I will give the assignment also. And next lecture, I will take that MCQ test in quizzes.com. So I expect. So what I will do today, I will update that study material sheet in that you can refer this study material. So on Monday, there will be a lecture. In that lecture, I will take that MCQ test. Okay. So that's it for today's lecture. And I will again repeat. So those who are having the backlogs in last year or last year, sorry, backlogs of second year. So they should fill that form provided by the university, which is forwarded by me. Those who were uh, all clear means they had backlogs, but in rechecking they have cleared the subject. So they should personally contact me. Okay. And those who are all backlogs, they should fill that form, right? Those who are regular, they can relax and chill. Okay. So quickly, I will take attendance, then we can stop. Okay. Another thing, we are now setting papers for the last year exam. So this last year exam, they are taking in online mode. So 50 marks question papers will be there.